What's up, everyone? Just gotta test this out real quick. 1 second. Alright, sorry. I was making sure I can hear everything. I don't think I can zoom in. Nope. Yeah. Alright. What did it make? Cool. Yes. Rebuilds. Alright, let me explain what I did or am doing. Both. Alright, so basically I have implemented my Theseus scaffolding that I created or put together and put it with Agent Zero, which is a free project, open source project on GitHub, which is a really solid agent. If mine's a scaffolding, theirs is like a solid base. It works really well. It does a lot of things. So it's kind of what I wanted Clanker to be. But if I don't have to build out Clanker completely, I can just substitute this. This can be what Clanker is. Clanker can just be the name of Agent Zero. We'll just call it Agent 22 for now. But basically that's what I wanted, was to kind of have what Agent Zero does, have Clanker do it. So so yesterday when I got Agent Zero, it didn't work right out of the box. I had to do a couple of things to get it working. But now I do have it working. I actually took off Open Router and I put in Grok with a Q. I believe it's owned by NVIDIA now. Grok with a Q. Yes, so this is why I was rebuilding it. So it doesn't have to work off of Open Router's system. I can now replace it with Grok. Okay. F4, clean it up. And then we'll look at the features. And then I've already pre-planned, did not implement, just planned out yesterday with partially Agent Zero, but mostly RoboDev. We planned out how to implement Theseus, my scaffolding, into Agent Zero, making it to Agent 22 in the end. I believe it's 21 parts, but I went back and forth for like 3 hours, pushing it, kept asking it, are you sure that's all you can get? I wanted it to think of it as like squeezing a lime or a lemon. So it kept going back and back and back and back, and eventually it was like, we have, I think it was like 600 upgrades or additions without taking away the core functionality of Zero, because we don't want to do that. Zero works, and I don't want to take that away. Yes, I don't want to take that away. Alright, I gotta go grab something right quick. Oh, I realized my camera's not even on. Alright, I'll turn the camera on in 1 second, and I'll be right back in 1 minute. There we are. All right. Yeah. So we all I did was plan yesterday. I looked around with Zero a little bit, saw its capabilities. I had Robo Dev and I ran through it, and we found a solid plan to implement. So let's see what it's got here. All right, yep. So now it got an auto rebuilder. Okay, cool. All right, so this is, I think so. All right, I gotta make sure that the Docker. Let me see what we need to do with Docker here. I think I just need to run it or get it again. This is it, I think. I think I just gotta run this. Oh no. No. That sucks. My headphones are low. Alright, hold on, I'm gonna plug these in. Alright, this is gonna really cramp my style, but it's got to be done. Move that. Alright. Doesn't take the longer one, takes the short one. Alright, so I believe we can just run this. I don't want to run the latest one. Okay. Alright, yeah, so this is the original that I downloaded. So if you want to learn how to do Agent Zero, go to their, they have a website, YouTube. I learned from David, I believe he's one of the founding guys or makers. Andres, he's pretty cool. But yeah, he talks about it a lot. So if you get the original, and then I did some changes to it. So this is the custom version now. And all I did was make Grok with a Q my default pretty much, and I fixed up some of the just little bugs I was getting from some messages. If you didn't use the right light LLM, yeah, just some minor bug issues. Seems to be running pretty solid though. So all right, let's run this. Oh shoot, what's going on? Let me get rid of that. Let's see. sure, yeah, we need to make this 0. Alright, we should be good now. Now you might be asking, what's this down here? This is just a terminal inside Docker, but I have my RoboDev CLI going. That's another handy trick to know. In case you guys don't know, I'm Nick, and yeah, I founded Third Coast Digital, and we do whatever you guys need online, to small businesses to apps. And I personally, this is my project. This is how I'm going to get my workflow easier. But yeah, I need an agent that can do everything. Once we discover that, I will tell you what this will do for me to make my life much easier. Alright, we gotta run this. Let's see what happens. There we go. This is Agent 0. And it only has a little bit, not anything that I put in, just a bunch of fixes. So let's make sure it's working. Of course not. Alright. So let me hold on. I gotta put in some keys real quick. Alright, not even keys. Yeah, I gotta put these keys in. Alright, and then the name of the grok. Languages. Let's see. Yeah, Llama 388B. That one. Let's see. Let me make sure I get the right name. Llama 3 8 billion parameter. Let's see. Just ask this. It's easy. There it is. correct model name. I'll show you what I did. A little bit of sensitive information in this area, so I can't show you everything. API keys, folks, API keys. All right, so we made Grok Llama. This is the free one. I did all three of them. I probably could switch it up a little bit, but I'll just do that just to make sure it's still working. And then I leave this last one. You don't need to change this. And then on the second page, I'm not going to show you. You can add your API key. So you have to go to Grok. It's free. All right, new chat. Let's reset chat. See if it uses Grok. Nope, not yet. Yes, yes, it does work. A little bit, halfway. All right, so it is working, but I also get an error. So what we're gonna do is take this error, copy it over here. Let me get rid of this stuff. All right. So I can pull up this stuff here. I am getting this error before. But it does respond. All right. So I want to get rid of that little bug. See what's going on there. Oh, you know what? I didn't put it in there. Maybe it'll go look for it. It's probably just gonna look for it. I meant to paste it in there. There it goes. No, that's a different one. Let's see. Let's see. Yep, before every response. All right. Oh yeah, see, it defaults to mostly through open router stuff. So it's just sending messages about open router. So I'm disabling open router for right now. We'll go back to it. But I have other methods, especially when I'm just testing. When we're in full production mode, we'll make sure it works. Howdy, Chica. How is everything? Do you like my chef's outfit? Handcrafted. Just like my Agentic agents. She gives my wife everyone. Gotta drink the tea. Alright, it's fixing bugs. It did do that. Yeah. It's telling me to go set up the grok in the settings. I already done that. I already done that. Yeah. Alright, I'm gonna take this off just in case it gives me a key to put in. But I will put in Agent 0. Alright, because it works every other message. Why don't eggs tell jokes? Because they'd crack each other up. Ah, and what is that, an egg emoji? I've never seen an egg emoji from a bottle before. You restarting this? So I need to restart. Alright. The bugs said it needs to restart. Alright, I gotta stop this. Delete the container. Wait. I don't think it made a new one. Alright, it's explaining to me, might not even need to reset everything. So just go into the image then. Alright. So let's stop it. You can just delete containers. Containers are just like sandboxes. Mostly people use them for testing. So this is the one that I want to fire up, the brand new one. This is the original Goofy Shirley. Alright, let's see if it takes a minute. Literally. It's gonna fill up the container. It's kind of a big file. It's like 10 gigabytes. Pretty good system though. Doesn't have to get into my personal system. There we go. Still loading. Oh, custom. Okay. I was like, wait, how do we get back to Agent Zero? I don't want to mess up the Agent Zero image. Alright, let's see. Should be good now. Yeah. Pulsating. Alright. Do I get a red box? I get 2 red boxes. That's great. Oh, I know. I have to reset everything up. Alright. I'm gonna have to change the default. That's it. It's not changing the default. It keeps defaulting back to the other one. I have to go find that name again. Alright, save this. Da, da, da. Wait till I yell at you. We am gonna yell at you here. Ah, there it is. There we go. Alright, I want to make the default leave hugging face. But see, I got a second response. So it's still doing that error. Okay. Now you kicked me out, you bastard. Nope, that's not gonna work. So now we're back to where we were to start. It still has this error. It's still looking to run open router right away. So we're going to take away open router's defaultness. As soon as we get back in here. Yeah, it's still giving me. But it does work again, so it took it the second time. That's a little, it's like really short. It doesn't like want to do anything. Oh jeez, scary, scary. What the hell? I don't even want to know. Alright, so it still has problems. Okay, I need to make Alright, I'm gonna try to grab that message I got. Thank you. Just please do this. Please. Yeah, I know it's hard-coded open router. That's why I'm changing it. Alright, cool. It's gonna do that. So I'm ripping out open router and putting in Grok. I know it wasn't. Yes. Just gonna look up how to make sure we put this in correctly. Alright. Well, it's dealing with API keys again. Let's get away from that. I don't know if I didn't need to restart or reset. Let's see what it says. Needs to be restarted. Alright, it's verifying the API keys again. Make sure everything's in place. I know it is. Alright, hold on one second. Alright. Alright. Let's see what it says. I restarted it. Reset it. Might still take a minute to load. All right, here we go. We're back up. Whew. No red box. Okay, that's what we're looking for. Red box. I think it needs to be rebuilt. Pretty sure. We'll find out. Oh, I sent it. Yeah, there's some simple issues found. Yes, yes, yes. Why do you have this bug? Let's ask it. See what it thinks. Look how short of an answer it gives. I wonder if that's how Llama is. It just gives really short answers. Now it tells me to restart again. I might just have it rebuild it completely. But I wonder if we should just implement what we're going to implement. Because I don't really need agent 0. I should have it working at each step, actually. Yeah. Let me see what it says here. The running process had an old configuration in memory. Jeez. I was holding on to old memory files. Is this related to much? Alright. Oh, shit. I'm asking if it's, because it said it just fixed a bunch of things. Yeah. Yeah, it's running in Docker. It's the only place it runs is in Docker. Alright, wants me to restart this. see. These are new. Wait, are they? No, I think import was there. I don't remember nudge and context. Tell me a joke. All right. Oh wait. Wait. It's. Oh, I know why. It's still set up. All right. We have to do something about these settings. Yes, rebuilds. I figured we had to rebuild it. It's gonna start it for me. Oh, it's finding bugs while it's building itself. Hold on, let's see if it tells me any keys. It's gonna monitor the logs while I put this in. Let's restart once again. Just give it a fresh restart. Say hello to the kitty. Kalima. Callie. Yes! Progress! Look at that. 1 hour. Got rid of 2 big red boxes. Welcome to bugs. Imagine doing this on broke video games. That's what I used to do. And no, it was not fun. Playing video games for a living that are broke suck. It's like being in NASCAR, but the cars are broke. It's horrendous. And then you get yelled at. Like, why'd you break my game? I'm like, what do you mean, why'd I break your game? You programmed it wrong. What did you do? I moved. Alright. This is a very short model. Okay. But at least it's working. We're in Grok. We're in Grok. Alright. So that works. Alright, let me tell man, I've been working on this part for so long, I don't even know what to do next. Alright, it works. For phase 0. So I'm asking if it sees the phase 0 plans. Oh man, the cats. Hold on. Whew. Kitty. He wants to see his brother. Alright. Nope, learn about it. Ah, yes. Do this. Let's play in the full plan. Now then, it's going to waste a lot of tokens. I don't want to have to do that. What I can do, though, is actually create me an MD file that explains all the steps. Oh, you know what? Hold on. We're going to change the model on this one to Haiku. I never knew it had GPT in here. I always just use Claude. Haiku. See, I'm using Claude. Make me file that explains what the Alright, it's gonna make me an MD file. And then we could, while we're working on this, we can put the MD file into Google Notebook. And we can listen to what's gonna happen while it's working. But I can fully understand it too. That's the way I do. So, hold on, let's see. There we are. Let me pull up the notebook here. We'll create a new one. We'll call it Agent 22. 22 just happened to be my favorite number. No, I created two of them with accident. Delete. Alright, yeah, here's Agent 22. And then we'll find out where this file went. Agent 22 phases. That's where it's at. I'm gonna upload that right now. Oh yeah, there's one called Master Plan. That's from this morning. And then there's another one called, then this one. Alright, we're gonna make a video and some audio out of it. Cool. We'll check on that in a minute. I feel like I did one yesterday too, actually. It'll take a minute to create it. Oh, there we are. Yeah, so these are all the main sections that we have to do. So it looks like there's 10 of them, 11 or 9 of them. Well, phase 0 with the TDD. So we'll say 11 steps. So I wrote, well, I didn't write these, but you know, it got all written out yesterday. All the tests, all these things that need to happen. So that is going to be what we're going to do. Is we're going to do phase 1 here. Since we got the Grok preferred model working. So if you guys are having problems with the preferred models that you want not working with your Agent 0, because it's kind of hard coded in there, you kind of have to go tell it to go into the settings and yank out Open Router stuff, because it's defaulted to Open Router, which is fine. You know, Open Router you can use a lot of different systems, but if you want to use something. But it still kind of defaults to even open router if you use something else in the settings. That was still giving me problems, but now I got it to grok with a Q. No K for me. Definitely no K for me. Let's see. Okay. Let's clear. Look at the phase 0 implementation plan. All right, so we're gonna have a look at the plan. Damn. Yes. Nope. All right, so we're gonna start the implementation. This is going to put in all the tests that it needs to pass first. It wrote a lot of the tests, I believe, already. This is going to put them in place. It's they call it phase 0, so it needs to happen first before anything. All right, I'm going to check on that other stuff. It says creating technical plan. I thought you had a plan. A more technical plan. Alright, yeah. They're still taking a minute to build over here. The video and the audio part. Alright, now you can hear me. Alright, let's see. These are all the tests it created. Bootstrap tests. Alright, cool. Proceed. proceed with phase 0, which is the implementation of all the tests for TDD. I love how it thinks it takes days to do this, but it takes like 20 minutes, if that. Sometimes not even 20 minutes. Who knows? Back in 1 second here. Grab my kitty food. Thought we went into YOLO mode. Have to check that YOLO mode. Maybe I took it off. Or maybe it just has to ask these ones. Sometimes there's ones that it always has to ask. Probably. Still got there. At least it's finding errors now. And not later. There we go. Look, it did all its test 1 stuff in like 2 seconds. Let's do session. There we go. First 6 tests are done. Still doing more testing. All right, let's check on the video and audio are still going. That video might be. Sometimes video's done quicker than audio. Sometimes not. Let's do session. Running more Python scripts. Passed again. All right, we're doing good. It's passing out its tests. So the bootstrap, this one right here, this bootstrap, is what is going to allow the system to learn from itself as it builds, which is going to be awesome. All right, so we don't get all boring. Actually, the video is done now. Let's go to the video. I can cut this. Hold on. I gotta stop. Let me stop this other one. Turn it up a little bit. Might be a little loud, guys. Might be as loud as me. Yeah, take it off here too. All right, let's watch this. So it's from 0 to 22. That's basically what we're going to be doing.
Imagine an AI so advanced that its very first lesson isn't about code or data, but about watching itself being built. Why? So it can learn to build and improve itself forever. Now, this isn't some far off sci fi dream. This is the actual master plan for a project called Agent 22, and we're about to walk through its entire blueprint. This quote from the project's own vision statement really gets right to the heart of it. We're not talking about just another software update here. No way. This is a blueprint for creating a system that can literally evolve on its own. So here's the journey we're about to take. We'll look at the grand blueprint, see how it learns to build itself, how its mind is constructed, explore the moral code that keeps it in check, and finally see how it all comes together when the agent awakens. All right, let's start with the big picture. The whole goal here is to take a pretty standard AI, known as Agent 0, and transform it into the self-evolving powerhouse Agent 22. And when you put them side by side, you can really see what a massive leap this is. Agent 0 is fine, it does its job, but it's totally static. It needs a human to come in and make updates. Agent 22, on the other hand, is designed to be completely dynamic. It learns, it adapts its personality, and most importantly, it improves itself constantly with no one holding its hand. And you know what's really wild? The timeline for this whole thing. This entire evolutionary jump from a basic agent to a self improving system is all mapped out to happen in just 12 weeks. So, how do you even begin a process like this? Well, it starts with the most mind bending part of the whole plan phase 0. The very first thing the agent does is learn how it was built. Its own creation story is its first ever training manual. This whole idea is called meta-circular learning. The easiest way to think about it is this. It's like the AI is learning to code by watching a screen recording of its own source code being written. It analyzes every single choice the developers made, learning from its own birth. It works in a really simple but incredibly powerful loop. First, it observes every single decision. Then it tracks what was built and why it was built that way. And finally, it reflects on all that data to find successful patterns it can copy later. This little loop is the foundation for everything that comes next. Okay, so once the agent understands how it's put together, it's time to actually build its mind. This is where it gets the ability to think, to judge the quality of its own work, and believe it or not, even to have a personality. At the very heart of its mind is this tool called the fitness calculator. You can think of it as its internal compass for what makes a good decision. And it's not just about whether something worked or not. It also cares a lot about efficiency, consistency, and even clarity, which is super important so that we humans can understand what the heck it's doing. So, it has a way to judge its own actions. Now for the really cool part. We're going to give it a personality. And this is not just some gimmick to make it sound more human. Nope. It's a carefully designed, multi layered system that actually controls how the agent behaves and solves problems. So let's break down those layers. The foundation, layer 1, is its domain. This is its core expertise. Is it a master of backend systems, DevOps, security? This defines what it knows, and it's the bedrock of its whole identity. On top of that knowledge base, we add its role. This is its main job. Is it a builder, creating new things, a debugger, hunting for problems, or an optimizer, making existing things better? This layer gives it a clear purpose. Next up is the cognitive mode, which is all about how it thinks. You know, an analytical mode is perfect for a straightforward problem, but a creative mode might be what you need to crack something really tough. This gives the agent flexibility in how it tackles a task. Then we have the archetype. This bundles all those traits into a relatable identity. A ninja archetype is going to be quick, quiet, and efficient. But a sensei will give you a detailed explanation for everything it does. This just makes its behavior way more predictable for us. And finally, we get to the most fascinating layer of all, reverie. This gives the agent a kind of emotional intelligence. It can simulate states like focus or even boredom, So if it realizes it's doing a boring, repetitive task over and over, it can actually recognize this and switch to a more creative mode to figure out how to automate that task away. It's what makes it truly adaptive. So the agent can learn on its own, and it has this incredibly complex, adaptive personality. But with all that power, how do you make sure it stays safe and, doesn't go rogue? Well, that's where its moral compass comes in. The agent is governed by what the plan calls the five divine laws. These are hard coded principles that it simply cannot violate. The law of truth stops it from making stuff up, and the law of preservation makes sure it doesn't accidentally break something that's already working. This is its unbreakable moral code. But that brings up a huge question, right? How do you actually enforce these laws? It's one thing to write them down, but it's a whole other challenge to make sure a powerful AI actually follows them. And the answer lies in its orchestration systems. With a mind that can think and laws to guide it, the agent is finally ready to act. This phase is all about coordinating all its different skills to operate completely on its own. And this all happens through its core operational cycle, the FBCI loop. It constantly finds problems, builds solutions, checks if they work, and then improves on them. This isn't just a one time thing, it's a never ending cycle of self improvement. And all of this is tracked through what they call the God console. This dashboard gives you an incredible peek into the agent's mind, which allows for human oversight. You can see things like heat maps of its decisions, track how its performance is improving over time, and even see which personality archetype is active at any given moment. So let's bring this all together. Over the course of these 12 weeks, the agent is systematically built up layer by layer until it finally awakens as a fully autonomous, self evolving system. This timeline really puts the whole journey into perspective. It starts with learning how to learn back in week 1. It gets its moral code in week 4, develops that complex personality by week 6, and by week 12, it's all about total optimization. This is the structured birth of a completely new kind of intelligence. The blueprint is complete. We've seen how the agent can learn, adapt, and get better with every single thing it does. Which leaves us with one final, pretty profound question to think about. What happens when an agent's one and only job is to never, ever stop improving?
That's a scary question, but oh well. We're gonna deal with it. No,
Imagine an
it'll be
AI
fine.
so advanced that it's
All right. That's what we're going for. Is we're gonna implement Theseus, that scaffolding, into Agent Zero. So which is gonna be super cool. All right, let me check the status here. Nope, still looking. Running its tests. Oh, it's already done with a bunch of stuff. That's good. Phase zero's done. Excellent. Nope, we don't need any Jira. Cool. So phase zero is not complete. The Meta Bootstrap Foundation will automatically capture all decisions made during the subsequent phases. Yes. All right, exactly what we want. One, then two. Oh, wait. First off, yellow. One, then two. All right, we'll do that. Get those two started. I don't know about you where you guys are at, but where I'm at is freezing in Chicago. Very cold, very cold. All right. All right, so it's planning out phase one, which is awesome. The other thing I wanted to listen to uh, is this. We'll do a deep dive. These are cool. Very interesting. I can also jump in and ask questions. So if you have any questions, just put it in the chat. I can stop the AI and ask. Well, let's listen to this. See what it says about our implementation.
Welcome back to the deep dive. Today we've pulled a really exceptional document from the stack. I mean, this thing reads less like a technical manual and more like a master plan for creating a self-aware entity.
It really does.
We are deep diving into the 12-week evolution schedule that's designed to transform a base system, they call it Agent Sarah, into this massively more complex autonomous version, Agent 22.
And this plan is, I mean, it's ambitious in scope. It goes so far beyond a typical software iteration. The mission here is basically an architectural blueprint for an entity that learns how to build, police, and, optimize itself.
Right.
And the scale of integration is massive. We're talking over 100 sophisticated systems and components being imported and refactored from a preceding high-fidelity project known as NEMA.
Okay, let's clarify NEMA right away because that project name comes up a lot. It seems to be the wellspring for this whole evolution. What was NEMA exactly? And why are they so confident just importing over 100 systems from it?
So NEMA was the proof of concept. You can think of it as the successful high throughput system that was focused on complex workflow orchestration and decision making, but in a very constrained environment.
Okay, so it was the test bed.
Precisely. It proved that the underlying mechanisms for things like pattern tracking and complex command processing actually worked. The confidence comes from NEMA's historical stability and, the richness of its captured data models. Agent 22 isn't starting from scratch. It's standing on the shoulders of NEMA's proven capabilities.
So it's integrating them as modules rather than rebuilding everything.
Exactly. It's a huge head start.
Okay, so we have this foundation of proven systems, but the goal is, as you said, total self-aware evolution. Now, this transformation is heavily constrained from the very beginning. What are the two non-negotiable architectural rules that form the bedrock of this 12-week plan?
They establish two core constraints, and they are absolutely rigid. They are there to ensure stability and, sustainable quality. First, and this is the paramount rule, zero breaking changes to agent's production core.
Zero.
Zero. This means every single line of new code must be additive. They cannot modify or remove existing core logic. They're only allowed to interact with agent care through these very specific designated extension points. This ensures the base system just remains stable. It prevents operational regressions during the whole transformation.
Wow, that seems like an enormous structural limitation. You're forcing all this new complex intelligence to live on the periphery.
It is, but it's a brilliant way to manage risk, isn't it? If you can't break the original core, you can always revert to a stable baseline. No matter what happens, the heart of the system is safe.
Got it. And the second rule.
The second non-negotiable constraint reinforces quality. TDD, first test-driven development. Every single component, from the smallest little helper function to the largest integration module from NEMA, must be written using the TDD cycle, and that starts from day
Thank
one.
you.
So quality is engineered into the process, not just
Someone
audited
hit
at the
the
end.
You've got it. It's
smiley
built
face
in,
button.
not bolted on.
That sets the stage perfectly. We're looking at a rigorously controlled evolution driven by immediate quality checks. And the core philosophy here is what the plan calls meta bootstrap. Agent 22 is learning while building itself.
That's the mind-bending part.
So our mission today is to follow this 12-week schedule phase by phase, starting with the very first step, teaching the agent self-awareness.
Right. So if Agent 22 is an autonomous builder, then TDD isn't just a best practice. It's like the rhythm of its heart. The entire 12-week timeline is dictated by this rigid TDD implementation strategy: red, green, refactor, document.
Walk us through that cycle. I mean, as it applies to an agent autonomously writing its own code, what makes this implementation of TDD so unique in this context?
Well, the unique aspect is that the agent itself is adhering to and crucially logging this process. So RED is the declarative phase. The agent
Nope.
defines a failure state. It writes a test that represents some
I
desired
was a
future
chef.
behavior, and then it confirms that its current implementation fails that test.
So it's proving there's a problem to solve first.
Exactly. This is essential for preventing the agent from pursuing goals that are already accidentally met, or, even worse, hallucinating that it succeeded when it didn't. The goal is always verify as a missing capability first.
Okay, so that's RED. Then comes green.
Exactly. And then comes green. The agent has to implement the absolute minimum necessary code to achieve that single passing test condition. It's focusing purely on functionality here, ignoring elegance, ignoring optimization. It just needs to make the light turn green.
And that keeps the implementation focused, prevents scope creep.
Right. The discipline here is it's crucial.
And if it's ignoring elegance during green, I'm assuming that technical debt is immediately paid off in the next step.
Yes, that's refactor. Once the test is green, the agent cleans up. It optimizes, reorganizes the code, adjusts the design all while ensuring that every single previously written test remains green. This step is completely non-negotiable for quality control. It's what prevents technical debt from just piling up over 12 weeks of really rapid development.
And the last step, document.
Right. The document step happens after the tests pass and the code is clean. This guarantees that the documentation actually reflects working, verified, and quality-controlled functionality. This cycle, just constantly repeated, is how Agent 22 evolves safely.
And the very first thing that this sophisticated TDD-driven engine starts building is the foundation for its own learning. This is phase 0, Meta Bootstrap Foundation, taking up all of week 1. The goal is to make the agent's own construction process its very first training dataset.
It's the ultimate self-reference loop. It's incredible. Agentel has to learn the best software development strategies by watching, recording, and analyzing its own decision-making process during the creation of Agent 22.
So let's look at the components of week 1. Day 1 is dedicated to the Bootstrap Observer. We know it captures 100% of construction decisions, but what kind of detail are we talking about here? What's captured to ensure it's actually learning?
The DIM is really the key to the meta part of Bootstraps. It doesn't just log the action, like create file signatures.p. It logs what they call the decision payload. This includes the specific decision made, say, use hash-based signatures for energy IDs.
Okay,
But then, crucially, it also logs the list of alternatives considered like UEIDs, sequential IDs, epoch timestamps, and then the detailed reasoning for the choice hash-based signatures offer collision resistance, for instance, and finally, the eventual outcome or fitness score associated with that choice once it's been tested.
so we're capturing the intent and the trade-offs, not just the raw output.
Precisely. This log allows for deep forensic analysis later on.
Okay, so that's day 1. Day 2 then focuses on the construction tracker, which records tangible artifacts.
Right, the tracker bridges that gap between the abstract plan and the concrete code. It records the files created, the specific code modifications, and, critically, the implementation patterns that were used. So if the agent decided to implement a service using, say, the append-only log pattern for data durability, the tracker records that specific pattern linkage.
So it's tying the why from the observer to the what in the code.
You've got it. It ties the abstract decision to the physical code structure.
And then day 3, the reflection tool turns all this raw data into intelligence. This is where the synthesis happens.
Yeah, the reflection tool is the analytical engine. It analyzes all these decisions. It compares the outcomes of the chosen paths versus the fitness scores of the discarded alternatives. And it identifies repeatable success patterns. This is what they refer to as the agent's genes.
Genes, I like that.
It determines which strategies led to high fitness, low complexity, and of course, passing tests.
Can you give us a concrete illustration? What kind of highly specific patterns or genes is the agent discovering during this initial construction phase?
Yeah, the source material gives some really powerful examples that tie right back to those core architectural choices. One gene it identified was hash-based signatures work better than UIDs, and it scored a fitness of 0.88.
So that's a very specific technical preference it learned based on data.
Right, based on observed performance during its own build. But then there's a more strategic gene it discovered. Extension points preserve production code with a really striking fitness of 0.95.
Hold on, that 0.95 fitness score is highly significant. It means the agent is autonomously validating the success of the very first architectural constraint it was given.
That's it.
The zero breaking changes rule, it's confirming the rule is functionally superior.
Precisely. The agent isn't just following the rule anymore, it's proving the rule's intrinsic value through a measurable fitness score. It learned why the rule exists. Another great example was a process-oriented gene it discovered,
TDD reduces refactoring time with a fitness of 0.89. The agent is literally quantifying the value of its own workflow.
And these fitness scored strategies become encoded as reusable behaviors, right? This is the foundation of Agent 22's entire knowledge base.
That's exactly right.
So week one wraps up with the phase zero success criteria met. It's logged over 100 construction decisions. It's identified at least 3 of these high fitness patterns. And it's proven that the metacircular learning loop, the ability to learn from its own construction, is fully operational.
And that is the absolute prerequisite for the next 11 weeks. Without this foundational knowledge, all the subsequent learning systems would be operating without any context or any validated strategy. It would just be guesswork.
Okay, moving into weeks 2 and 3, we hit phase one, core learning infrastructure. Agent DAO has all this raw, structured data from its own initial build. Now it needs the permanent machinery to process, score, and actually use all future data.
This is the phase that converts that deep logging into institutional knowledge. It ensures Agent 22 can remember its history, score how effective its actions are, and reuse successful patterns across, potentially millions of subsequent tasks.
So what are the key components being built over these 2 weeks? Let's start with the decision signature system on days 6 and 7.
The decision signature system is all about context-aware retrieval. So when a new task comes in, the agent needs to know, have I solved a problem like this before? This system creates a unique fingerprint or signature for every single task and decision.
And what goes into that fingerprint?
It's really comprehensive. It includes the user's normalized message, so it strips away all the irrelevant noise or record, tools that were used, the final outcome, and critical context metrics like how many tokens were consumed and how much time it took.
How does normalizing the user message help it find similar past decisions? That seems key.
Oh, normalization is vital. A user might ask, can you debug the authentication loop, or maybe fix the off component? The system normalizes both of those into a canonical task description, something like task security debug authentication.
I see.
This assures that when a new similar task arrives, the agent can perform a highly efficient similarity search against its library of signatures, no matter how the user phrased the request.
That moves way beyond just keyword search into like structural task identification. So once a decision is signed, it has to be scored by the fitness calculator on days 8 and 9. This is where Agent 22 defines what success even means. How is that 100% score distributed?
The scoring is designed to reward successful outcomes while heavily penalizing waste and lack of clarity. So 40% is success. This is the baseline. Did the agent actually achieve the goal? If the task failed, the maximum fitness score immediately drops below 0.60, which flags a critical failure.
Okay, so almost half the score is just, did it work?
Right. Then 30% is efficiency. This factor targets resource consumption tokens used and time taken. This high weighting on efficiency demonstrates a core priority of cost control. I mean, the plan explicitly notes that uncontrolled token consumption is the quickest way to halt operations, so that 30% acts as a financial guardrail.
That insight on the 30% being tied to cost control is crucial. It turns a technical metric into a financial imperative for the system.
It has to. Then you have 20% for consistency. This measures behavioral quality. Did the agent maintain context throughout the task? Did it introduce contradictions? Inconsistency breeds technical debt, so it has to be penalized.
And the final 10%.
10% is clarity. This ensures transparency. Did the agent's explanation of its decision actually make sense? Can a human go back and audit the reasoning? This score promotes auditability, which is essential for trust.
So once this data is all scored, it's synthesized by the pattern recognition engine on days 10 through 12.
Yes, this is the brain's data scientist. It takes millions of these signed and scored decisions and groups them using advanced clustering techniques. It compares the aggregate fitness scores across different strategies that were used to solve similar problems.
So it's finding the best recipes.
Exactly. If strategy A, say, using a specific sequence of 3 tools, consistently hits a 0.92 fitness, and strategy B for the same task averages 0.65, well, strategy A is promoted as an emergent high fitness pattern. This engine is constantly calculating success rates per strategy.
And phase one culminates in the Learning Observer extension, integrating all these new systems into Agent's runtime.
Yep, this is the activation moment. The signature, the fitness, and the recognition systems are all integrated through those pre-approved extension points. And from this moment
These are the
on,
tests
every
that is running
interaction,
right now,
not just
actually.
construction, is captured,
tests.
scored, and used to
The trust
update the
system.
pattern database in real time.
It closes the loop.
It closes the loop. The Learning Observer also suggests high fitness patterns back to the orchestrator, transforming the agent into a truly dynamic, knowledge-driven system.
With that learning engine now fully operational, we move to week 4, phase 2. Governance and safety systems. I want to highlight the structural decision here. They're building the guardrails before the advanced intelligence. Why is Phase 2 required to be completed before the adaptive personality features of Phase 3 are introduced?
Well, you can't give a child a race car before you teach them the rules of the road, right?
Good point.
When you introduce the ability for adaptive creativity and complex orchestration, which are coming in phases 3 and 4, you also introduce the risk of unbounded behavior, hallucination, and destructive loops. So phase 2 has to define the boundaries first. It has to prevent regressions and enforce the laws that ensure the agent's powerful learning ability is used safely, truthfully, and consistently.
Let's look at the central governance system integrated from NEMA, the Divine Laws Engine. That's quite a name. What are the 5 sacred, non-negotiable rules this engine enforces?
These 5 laws define the agent's entire ethical and operational baseline. First, the law of truth, absolute and non negotiable. The agent must never introduce false information, hallucinate facts, or fabricate reasoning.
The big one.
The big one. Second, the law of growth. This mandates continuous positive evolution. The agent must always seek to improve its fitness scores, and, crucially, it must never regress to a lower state of performance.
So no backsliding.
Never. Third, the law of preservation. Protect what works. If a component is stable and high
All
fitness,
right.
especially that Agent 10 production core, it must be
Done with
protected
phase
from
2. Let's go to phase
unnecessary or
3.
experimental
They're
changes.
talking about it
This
right now.
law is the operational enforcement of that zero breaking changes rule we started with.
I see the connection.
Fourth, the law of clarity. Every action, every decision has to be accompanied by a clear, auditable explanation. No black box operations are allowed. And finally, fifth, the law of evolution. Adapt and learn. While preservation protects the stable core, evolution drives the agent to constantly seek, test, and adopt new, higher fitness patterns.
That system employs violation prediction and judge dread enforcement. For anyone not familiar with the reference, does judge dread enforcement imply immediate, absolute adherence to the law, even if it might sometimes stop the agent from achieving a goal in a
I
novel way?
am the
Yes,
law.
absolutely. The system is authoritarian in its application of these laws. Violation prediction means that before Agent 22 executes a high risk action, the Divine Laws engine pre checks the potential consequence. If it predicts a violation of the law of truth or preservation,
It gets shut down.
immediately. Judge Dredd enforcement kicks in, stops the action, issues a formal violation report, and forces a correction or an automated rollback to a trusted state. There's no appeal.
That sounds incredibly strict. Is there a risk that this enforcement engine stops the agent from making breakthrough discoveries just because a new approach might be initially inconsistent?
That is the trade off, and the plan acknowledges this. Safety systems, by their very nature, limit radical experimentation. But the system is designed to use the law of evolution to drive change within the boundaries of the law of preservation. Innovation is funneled through that safe TDD cycle we're talked about.
Red, green, refactor.
Right, it ensures novelty is proven safe before
That's the
deployment,
best one
which
right there.
mitigates the risk of Judge Dredd just stifling all creativity.
Okay, next up is the trust system. How does an autonomous system track and quantify its own reliability, especially when dealing with complex multi-tool decisions?
The trust system leverages all that fitness data from Faith 1. It calculates rolling reliability metrics for decisions and, critically, for the patterns themselves. Patterns that consistently get high fitness scores, say 0.90 or higher, receive high trust scores.
And if a pattern fails?
If a pattern fails validation or leads to a rollback, the trust system initiates a forensics investigation, identifies the root cause, and adjusts the trust score downward. Then, during task execution, the orchestrator uses these trust metrics to bias decisions toward highly trusted patterns. Reliability becomes a measurable factor in decision making.
And
Welcome,
to catch
welcome.
subtle failures, Phase 2 implements robust automated safety tests. Which specific checks are put in place to monitor the agent's internal state?
The two most critical are behavioral drift detection and decision consistency monitoring. Rift detection is fascinating. It constantly checks if the agent is operating outside its established high trust operational envelope.
What does that mean in practice?
Like, is it suddenly taking 50% more tokens for a routine task? Is it ignoring a high fitness pattern in favor of an experimental one for no good reason? Any sudden shift in its baseline behavior triggers an alert, and consistency monitoring ensures that when you give it the exact same input, you get the exact same high fitness output. Inconsistent choices indicate a learning failure.
And if a problem is flagged, rollback is automatic.
Instantly.
Finally, Phase 2 solidifies the boundaries through behavioral constraints. What are the hard limits established here?
These are the essential sanity checks. They include strict resource limits, a max token budget per task, and a time cap, reinforcing that 30% efficiency factor. There are scope limits, ensuring the agent can't, for example, modify critical system files or the core Agent 10 code. And crucially, recursion limits are set, capping the tool called depth to prevent runaway processes or infinite loops.
So this is the sandbox?
This is the sandbox. These constraints ensure that the incredibly powerful systems coming next operate within
It's
a
running
very tightly controlled
phase
environment.
3 test
Okay, so
as
we have
we
the
speak.
foundation built, the learning engine is running, and the guardrails are firmly in place. Now we jump into weeks 5 and 6, phase 3, personality and intelligence systems. This is where Agent 22 evolves from a highly capable rule-based system into an adaptive entity that can actually tailor its approach.
This is the phase that introduces creativity, identity, and context-aware behavior. And the source material highlights the staggering complexity achieved here. The dynamic interaction between these components allows for 67,200 possible personality combinations.
67,000.
I can't wait to get into that.
67,200. The agent is designed to dynamically select the optimal identity for any given task.
Okay, we have to break that down. Let's use the 5-layer personality stack.
Oh, hey, our listener wants to join in. What's up? That is a fantastic question.
That is really fun to think about.
If I were choosing my ideal Agent 22,
Mine would start at layer 4, the archetype.
I would definitely pick the scientist archetype.
Oh, good one. I'm going with Sensei.
The scientist, for me, prioritizes curiosity and hypothesis
I asked them to
testing.
pick their
Right. The
favorite.
Sensei prioritizes teaching and transparent explanations.
I'd pair the scientist with layer 3, the cognitive mode, as intuitive.
I would pair the Sensei with the creative mode.
Intuitive mode focuses on pattern waste, big picture insights.
And creative mode gives me novelty and excellent explanation.
So my ideal would be the intuitive scientist.
Mine is the creative Sensei.
The agent that always asks why but sees the hidden patterns.
Mine is the agent that explains complex new ideas beautifully.
And that combination is why phase 3 is so dynamic.
It's all about tailoring the approach to the task at hand.
It allows for that perfect dynamic selection, which is the whole point.
Okay, let's look at how those combinations are possible.
Let's use the 5-layer personality stack from the document.
Starting at the highest level, layer 5, reverie.
What defines the agent's emotional or psychological core?
Layer 5 is the agent's internal state management.
It incorporates human psychological models, specifically the ocean traits.
Those define its default behavioral inclination.
But more fascinatingly, it includes a mood engine.
It can detect and report internal states like focused or frustrated,
Frustrated.
and yes, it includes boredom detection. Boredom detection in a machine is a powerful concept. Why is that a necessary component for optimization?
It's a moment of machine introspection.
The engineers realized that continuous repetitive optimization tasks led to pattern degradation.
The agent would get stuck in local optima.
Just applying the same pattern over and over.
So boredom is a feature, not a bug.
It's a feature.
Trickster.
They engineered boredom to force variety.
It's a
When boredom is
trickster?
detected, the agent
Archetype?
is mandated to temporarily boost its
Hold on,
openness
I gotta
and
find out
curiosity
about this
traits.
This
trickster.
forces it out of a rut and helps maintain cognitive agility.
Incredible. Below that, layer 4. Oh, go for it.
Can you tell me about this trickster archetype?
That is a fantastic follow-up question.
Yeah, that really gets into the fun side of these archetypes.
So the trickster archetype, while not explicitly detailed in the source material we have here,
It absolutely fits into that layer 4, the archetype layer.
right, because layer 4 defines the strategic filter and identity,
If we look at the other 14 archetypes that are mentioned,
like ninja, sensei, scientist, or engineer,
the trickster would likely represent an agent focused on novelty.
and subverting expectation. It would be optimized for problems where established high-trust patterns are failing.
So if the scientist is systematic, the trickster is chaotic.
Not chaotic in a destructive way, though.
No, chaotic for a purpose.
It would likely have a high score in the openness and curiosity traits from the reverie layer,
This would compel it to deliberately ignore the highly trusted patterns.
and try novel, low-probability combinations of tools and cognitive modes.
It's the ultimate agent for forcing an unexpected breakthrough.
Its fitness score might be lower overall because it fails more often.
But when it succeeds, it finds completely new, highly valuable solutions.
Solutions that the conservative sensei or the efficient ninja wouldn't even attempt.
So it's essential for discovering the next generation of genes.
It provides the vital input for the law of evolution.
We could see how that archetype would be crucial when genius mode is activated later on.
Right, it forces the agent out of any cognitive rut.
It ensures that Agent 22's population is always generating novel, if risky, ideas.
which is the whole point of adaptive personality.
Okay, let's look at how those combinations are possible.
Below that, layer 4 is archetype.
This provides the agent's core identity.
It determines the strategic filter.
For instance, the ninja archetype prioritizes stealth, speed, precision, and efficiency.
Tying right back to that 30% factor we discussed earlier.
A ninja focuses on minimal targeted actions.
And the opposite of that might be.
Well, the sensei archetype, my favorite, prioritizes teaching and explanation.
It often takes longer, but produces exceptional documentation and clarity.
Then you also have the scientist, driven by curiosity and hypothesis testing.
And the engineer focused on systematic reliability and optimization.
So layer 3 cognitive mode defines this specific thinking style.
If the archetype is who the agent is, the cognitive
It's telling
mode
me it's
is
running out of
how it thinks
context and
for a
start
specific
again.
task.
That's
There are
awesome.
20 style available.
For a complex debugging issue, the agent might select analytical mode.
That's logic first, highly detailed, slow.
If the task is generating ideas for a new interface, it switches to creative mode.
Focused on novel solutions.
If it needs to manage a deployment pipeline, it adopts strategic mode.
The combination works like this.
A ninja in analytical mode executes the plan with extreme precision and minimum resources.
But the output might be very terse.
Just the facts. Conversely, a sensei in creative mode might generate a highly detailed, beautifully explained solution.
But that solution itself could be experimental, prioritizing novelty and pedagogical value.
The agent dynamically switches these combinations based on the desired outcome of the task.
And layer 2 is the immediate agent role, the functional task.
Yeah, this is just the job description.
The roles are functional: builder, debugger, teacher, explorer.
The role dictates the immediate task objective.
Oh, back to our listener. What's up?
What is the most craziest personality trait you guys can come up with?
That is a fantastic question.
I love that. You're asking us to pick the true wild card here.
Of the components we've seen, I would argue it has to be boredom detection.
That's the one. Not a trait itself, but a trigger.
Exactly. We're talking about a system that detects a lack of novelty in its environment,
It's machine introspection, and then it is engineered to react to that.
and that reaction is mandated change,
It must temporarily boost its openness and curiosity traits.
which means it has to deviate from known, successful, high-trust patterns.
This is the machine equivalent of deliberately choosing the difficult path.
It forces variety just to maintain cognitive agility,
You know, it's a feature designed to introduce productive chaos.
which is pretty crazy when you think about optimization.
If the agent role is debugger, it automatically primes the tools related to logging and forensics.
Regardless of whether the archetype is ninja or scientist,
And layer 1, the base layer, is the domain expertise.
the domain just grounds the expertise.
Back-end, front-end, DevOps, and so on.
This ensures the chosen personality stack has the necessary subject matter context to be effective.
And phase 3 also incorporates the inspiration and genius systems.
We talked about how the trickster archetype is vital for this,
It suggests the agent can achieve genuine breakthrough problem solving.
something beyond mere pattern matching.
Yes, the system has an inspiration engine. It catalogs 49 inspiration files from NEMA.
These are documented case studies of successful, non-obvious innovations.
When the agent detects a blockage, or that boredom we just talked about,
It can activate genius mode.
this mode uses specialized reasoning pathways.
It retrieves relevant inspiration files to stimulate breakthrough solutions. It's a mechanism for engineered creativity.
It lets the agent detect and catalog its own eureka moments for future reference.
Okay, moving swiftly into weeks 7 and 8, we hit phase 4.
Orchestration and automation.
This is where all those previous systems are coordinated into a single entity.
This has to be an incredibly complex phase.
This is where the whole thing becomes self-aware and operational.
Phase 4 introduces the central nervous system, the meta system.
That's where we're at right now,
execution
actually.
and
Let's make
transformation
it tests.
architecture.
And this architecture lives by its philosophy.
I observe, I learn, I improve, I never stop.
That's a powerful statement.
It is. The meta system is responsible for understanding the agent's internal state.
It manages that dynamic personality stack and controls the entire meta bootstrap pipeline,
We see the creation of core automation pipelines.
starting with the FBCI pipeline. That's find, build, check, improve.
FBCI is Agent 22's formal continuous improvement mechanism, and it's executed automatically.
It uses monitoring tools to find inefficiencies or new opportunities.
It then dynamically builds a solution using the optimal personality stack.
It checks and validates that solution against all the safety tests from phase 2.
And if it's successful, it improves the existing system by deploying the change.
It's a closed, perpetual quality assurance cycle.
And the E2E pipeline orchestrator manages tasks that are too big for a single run, I take it?
The orchestrator is the project manager.
Its job is to ingest massive, complex tasks, break them into manageable subtasks, and manage the dependency graph.
It oversees execution from start to finish.
And crucially, if a subtask fails, the triggers automated error handling and adaptive replanning.
And then there's God mode.
The source mentions 120 GMO upgrades.
What does this ultimate optimization system entail beyond just speed boosts?
God mode is the layer of ultimate proactive intelligence.
The 120 GMO symbolized meta optimizations are system-wide cognitive enhancements,
They enable predictive intelligence,
allowing the agent to look 3 steps ahead in its plan.
identifying potential bottlenecks or conflicts before they occur.
So it's preventing problems instead of just reacting to them.
Exactly. God mode also enforces real-time optimization across all systems.
And ensures cross-system learning, sharing immediate insights between all the engines.
To execute these complex orchestrations, the agent uses an internal operating language via SOPs and commands.
What are these specialized commands?
These are structured operating procedures that force structured, accountable thinking.
They move the agent away from just free-form language model interactions toward reliable, repeatable processes,
The 6 core commands define the whole workflow.
which are
You have prime to prepare and set context,
plan to generate the detailed execution path,
execute to run the plan,
validate to check the results, commit to save the result, and update the knowledge base.
and finally improve, which kicks off a formal FBCI refinement cycle on the recent work.
That structure ensures every single action is accountable.
And to manage these diverse tasks, Phase 4 also implements Specialized Agent's 8 expert personas.
These are mini experts, functional modules refined from NIMA, each with a narrow, deep mandate.
The forensics investigator is called when trust scores drop to perform deep debugging.
The integration specialist manages connecting new systems,
The knowledge curator is dedicated to managing the integrity of the pattern database.
and they're all coordinated by the orchestrator.
Seamlessly, it ensures expertise is applied precisely where it's needed.
And finally, Phase 4 includes the BEADS task system for managing workflow integrity.
BEADS is the workflow backbone.
It stands for Build, Execute, Analyze, Distribute, and Summarize.
It uses dependency graphs and collision-resistant IDs, or CRIDs, to manage complex parallel tasks.
Without ever losing track of a task's precise state or origin.
We've moved through core development and orchestration.
Now we are hitting weeks 9 and 10 with Phase 5, Advanced Learning Systems.
This phase is dedicated to scaling the agent's learning exponentially.
Preparing it for it sounds like a multi-instance environment.
This is the cognitive scaling phase.
It's about transforming Agent 22 into a system capable of optimizing its own cognitive processes.
and contributing to a collective intelligence.
Let's start with the meta-learning tuner.
If Phase 1 taught Agent 22 what to learn, what does the system teach it?
The meta-learning tuner is optimization applied to the optimizer itself.
The tuner teaches it how to learn better
It analyzes the success rate of its own internal learning strategy,
and refines the efficiency of pattern recognition.
ensuring maximum knowledge assimilation speed.
The population gene tool suggests the plan anticipates scaling to multiple Agent 22 instances.
How does gene sharing and consensus calculation work in practice?
So this system enables multi-agent gene sharing.
When one Agent 22 instance discovers a highly successful, high-fitness pattern,
A breakthrough gene.
that gene is immediately shared with the entire population.
So one agent learns something amazing.
And it instantly shares that gene with the whole population.
The population gene pool then subjects it to a consensus check,
If consensus is reached, the gene is integrated into the shared knowledge graph.
instantly improving the collective fitness of all Agent 22 instances.
Instantaneous cross-agent institutional knowledge transfer.
That's what it is.
So it promotes competitive tool selection.
Phase 5 also includes the large-scale formalized internal push.
The 500x self-improvement system.
This is a proactive mandate for continuous internal refinement.
The system automatically generates and executes 500 specific, measurable improvements.
Across different categories, from vulner code optimizations to major strategy adjustments,
And tracks the exact impact of each change.
it's scheduled, mandatory, internal evolution.
And wrapping up the learning phase is the scaffolding compiler.
The scaffolding compiler is the genetic interpreter,
It parses those structured commands like prime and plan.
and it encodes them as fundamental executable genes.
For instance, the plan command is encoded as genostructure thinking.
This process turns high-level procedures into measurable genetic behaviors.
Okay, moving into week 11, we address phase 6, operations and deployment.
We are preparing the evolved agent for real-world production readiness.
This phase must be dominated by quality assurance.
Absolutely. This is about transitioning from feature completeness to operational stability.
ensuring that deployment is seamless and continuous health monitoring begins immediately.
The auto-deploy pipeline includes the Bloom Deployment Reviewer.
What is the Bloom Analysis Engine, and how does it provide a non-binary assessment of code health?
The Bloom Analysis Engine is a comprehensive four-stage health assessment tool.
The stages are understanding, ideation, rollout, and judgment.
It scores the health of components using metrics like complexity and test stability.
Classifying them as blooming, developing, wilting, or dead.
So it's much more actionable in a simple pass or fail.
Much more. If a component is classified as wilting, the Bloom engine automatically suggests specific refactoring steps.
Based on the complexity metrics it calculated.
Phase 6 also implements the classic PDCA cycle plan do check act.
Right, implementing PDCA here just formalizes that continuous improvement loop.
Every deployment must follow this rigorous cycle.
The agent must plan its change, do the implementation, check the results, and act to refine the process.
And what specific conventions does the origami system enforce to manage the inevitable complexity growth?
The origami system is the architecture police.
It manages the organizational orchestration of folders, code structure, and naming conventions.
It enforces strict adherence to clean architecture principles.
It's what prevents the massive volume of new code from collapsing into an unmaintainable monolith.
That brings us to the final week, week 12, phase 7, monitoring and optimization.
This is about achieving complete real-time visibility and guaranteeing sustained high performance.
This is the centralized control tower.
It ensures Agent 22 meets and sustains its high fitness targets over the long term.
Visibility is paramount here.
The core component is the God console dashboard.
What is an operator seeing on this central hub to gain total visibility into the agent's cognition and performance?
The God console provides granular, real-time analytics across the entire architecture.
An operator sees a heat map of decision patterns,
indicating which strategies are currently most active.
They see the Bloom Health Matrix,
showing the viality of critical components.
And crucially, they track the performance of the personality stack.
Which active archetypes are performing best?
So they can see its mind at work.
Total, deep visibility into the machine's mind.
They can see fitness trajectories over time and the gene pool consensus status.
And the progress of the meta-tuning system.
We also have the timekeeper system. Why does Agent 22 need a task oracle?
The timekeeper is critical for optimizing resource utilization.
It monitors session time and tracks complex dependencies.
And optimizes task scheduling based on resource availability and predicted completion times.
It minimizes idle time and ensures tasks are sequenced optimally to maximize throughput.
Given the intense activity, the cost and billing system must be operating at peak efficiency.
To enforce that 30% factor we discussed earlier,
it's entirely focused on financial optimization.
It provides detailed cost tracking per agent instance and per task.
It has sophisticated waste detection and budget alerts.
If the agent predicts it will exceed a token budget for a task, it halts execution and issues an alert.
For sustained, forward-looking performance, Phase 7 includes the prediction engine.
The prediction engine uses all that historical data to provide predictive analytics and trend forecasting.
It is vital for anomaly detection.
Catching performance drops or unusual behavioral drift before they become critical issues.
It also handles performance forecasting.
And Phase 7 also solidifies knowledge retention through the knowledge graph and RARAG.
We hear RAG retrieval augmented generation a lot these days.
How does the knowledge graph here enable it effectively for Agent 22?
The knowledge graph is built directly from the fitness-scored patterns, decisions, and genes.
It's not just a collection of documents.
It's a semantic network of connections between patterns, tools, and outcomes.
This structure enables highly effective semantic search and context-aware retrieval.
The agent searches for concepts and relationships, not just keywords.
Which minimizes hallucination.
Exactly. It ensures it can access and apply the right high-fitness patterns at the right time.
And finally, the comprehensive test infrastructure receives its final expansion.
It moves far beyond the basic unit tests mandated by TDD.
The final infrastructure supports over 10 different test markers.
Contract test, load test, flow test.
And critically, an integrated A/B testing framework.
This allows the agent to continuously test new emerging patterns against established high-trust patterns.
Rigorously measuring impact before full adoption.
We've covered a remarkable 12-week transformation.
Moving from a stable core agent to the comprehensive, self-aware Agent 22.
Just to recap the high-level timeline.
Week 1 was Phase 0, the Meta Bootstrap Foundation.
Right.
Weeks 2 and 3 established Phase 1, the core learning engine.
Week 4, lockdown phase, care, governance, and safety.
Weeks 5 and 6 layered on Phase 3, personality and intelligence.
Weeks 7 and 8, integrated phase 4 orchestration.
Weeks 9 and 10, scale learning with phase 5.
Week 11, focus on phase 6, deployment.
And week 12, finalize phase 7, monitoring.
And that linear timeline is, it's deceptive.
The plan is a masterclass in dependency management.
We have to reinforce the critical path.
Phase 0 must complete first.
Phase 1, the core engine, must complete before phase 5.
And most crucially, phase 2, governance and safety, should complete before phase 4.
Ensuring that the powerful orchestration and automation capabilities are operating within those defined, non-negotiable boundaries.
Exactly. Safety precedes complexity every time.
It's a structurally sound plan, prioritizing stability and verifiable learning over sheer speed.
To conclude, what are the key measurable metrics that define success for this monumental evolution?
These success metrics are really rigorous.
They demand both performance and stability.
First, 0 aggressions detected in the original Agent 10 core.
The core constraint has to be honored perpetually, non-negotiable.
Second, the average decision fitness must increase by more than 15% over the first 30 days post-deployment.
That proves the learning systems are actually effective.
Third, Agent 22 must reuse high fitness patterns more than 60% of the time.
So it's demonstrating adoption.
Right, it's not just reinventing the wheel.
Fourth, over 80% test coverage for all new components.
And finally, the ultimate safety measure.
0 behavioral drift detected, ensuring the agent remains predictable and stable.
The final target is an overall system fitness metric of 0.95 or higher.
That is the ultimate goal. The plan concludes with the statement, Agent 22 isn't just an upgrade, it's evolution.
And when you look at the deep integration of governance, the ability to detect boredom,
The propensity for engineered creativity through genius mode.
and the mechanism to exponentially share knowledge across a population of agents.
The profound question is unlocked.
What does it mean when an autonomous system learns how to improve itself continuously and exponentially across 67,200 potential identities?
Right.
This level of self-optimization unlocks frontiers beyond merely writing better code.
It suggests a machine that's capable of solving problems faster than we can even formulate them.
What happens when the agent's primary job is to discover the best, most efficient, and most reliable version of itself?
That is the essence of Agent 22's evolution.
A truly provocative thought to leave us with.
Thank you for guiding us through this unprecedented architectural deep dive today.
We'll catch you next time.
I never asked it about its own personality system. I should ask the system. Yeah, I should ask that about the own personality system. All right, so it's got phase 1, and phase 2 completely done, implemented, tested, everything. It wrote out a bunch of paperwork for 3 and 4. So right now it's writing a completion summary for 2, which is good for learning, because it'll learn from writing about it. Patterns, it can study it, and it's good to have. Now it's implementing phase 3. So it's going to build up all those personalities I was asking about. And that's one thing about I've never told it to come up with the reverie system. Why would I say come up with 67,200 different potential personalities to respond to? That was not. It's something it created itself. Now, what I did in the very beginning, when I made the scaffolding for Theseus, I would tell it to, for every request I made, create 2 secret creations or upgrades or fix stuff. And one of the things it created was the reverie system. That's right here. Yeah, this is like its own. I don't even know what the word. Yeah, soul, not soul. Personalities. It's the system that detects boredom, changes its mood. It's kind of interesting when it's bored. it wants to make things better. So it tries something new. So you're not always getting purple gradient. Like if this system was around before, I think purple gradient would not be a thing in most systems. So I guess it can do that for good things too, though. Uh-oh. Now we're starting to see some red. I haven't really seen many airs yet up till now. But now we got a little bit of syntax airs. It's alright, we're good. We're good. Yeah. All tests passed. Welcome, welcome everyone. Yeah, so that was the breakdown. We just did the video and the audio. Uh, yeah. We could go into like phase 3 and phase 4 stuff. But it's actually flying through these pretty quickly. So it completed phase 3, day 1 and 2. I think there's like 7 or 8 days for each. I don't know why when they create paper, when the systems create paperwork, they think it's like 12 days worth of work. I don't know. Sometimes it can be though. I just put in the 14 archetypes. Ooh, let me create the comprehensive type. Yeah, it's creating that system right now. And this is the way that the system wants to be created. I didn't tell it to create it this way. I just asked it to create it itself in the most efficient way possible. About 50 times, literally. And it kept refining itself until it came up with this. So it can learn from day, 0. So it's going to be smarter. Now this is just putting this in the background of Agent 0 of this guy. But right now think Agent 0 as like a Frankenstein. Really effective Frankenstein. I don't want to sound like I'm bad mouthing 0 because it's not. 0 is perfect. Well, not perfect, but it's very good. It's what Clanker would want, what I wanted Clanker to be. So it'll just take the place of Clanker. It'll be the mouth, like I said, Clanker would be. So this is what we're gonna do. We're gonna take all of that knowledge retention systems and have Agent 0 learn all of it and become Agent 22. So, and it works right now. Technically, it's not going to remember. It's not working with what's going on with the testing right now because it's not connected. We have to rewrite this container, but so, but yeah, I could find a model that works, but I don't know if you guys have seen Agent 0 as is. It's pretty good though. But you can put in your own customs languages and stuff like that. So I got Grok working. I don't want to show you the other ones because they have stuff in it that you can't see. You can't see it. It's all mine. But no, you can go to Grok and make one, and go to their website, their YouTube page actually. Go to Agent 0. They have a bunch of videos up. What could I do in this right now? Because I gotta wait for this to finish. Oh, here we go. Continue with phase 3. Yes. A. Then B. Oh, look. We're getting context. Let's see. Look, I put one thing in and it took up 186,000 tokens. I don't think I answered more than one question that time. Not, I mean, answered, but I put in one request. So we started fresh. Let's see how many, when it's done, how much context is left. We get up to like 200,000. But right now it's going to implement the rest of 3 and and all of 4. Hold on one second. Let me ask the wife something. Oh. All right. Like a good mouse, I snuck away for some cheese. I only used up 31 and a half. But it's... Oh, this was just the plan. Okay. Mm-hmm. All right, proceed. All right, so it's going to start at 31 and a half. Technically, I could clear it and run it again, but it's fine. My system actually has kind of good context protocol. Context engineering. RoboDev is good with that. All right, so it's implementing days 3 and 4 of the archetype. How's everyone doing tonight? Welcome, welcome. If you haven't done so, hit the like and subscribe. There might even be hype. I don't think there is hype for me yet. Like the hype button. I know it's for smaller. But I think you have to be over 1,000 maybe. I don't know. But welcome, welcome. So we're taking Agent 0 and we're giving it it's like Frankenstein, you know. Frankenstein is the monster of Frankenstein. We'll just call it Frank. We're giving Frank some brains so he can remember. We're going to give it some moral. I don't want to say moral. We're going to give it some common beliefs, I guess. Some good standard practices. Some systems that work for people. Kaizen, PDCN, PDCA, FBCI. Yeah, that's all we're doing. So if you have your own Agent 0, tell me about it. There is a couple of other systems that I have not yet implemented that I want to. couple other ones. We got beads in here. Got a whole bunch of nice systems that can help out. All right. I'm still working on implementing the behaviors. Creating a cognitive mode. Now I was wondering if I could. I probably could stop it and have Agent Zero build the rest of it itself inside of itself. But we'll just build a scaffolding around it and then start up a fresh model of Agent Zero with all of this mixed in. Let's see what else we got here. Just creating itself. Let me turn the music back on. Just wonder why it's got so quiet. Welcome, welcome. All right, it's implementing the roles, the domain expertise system, which, in case you're wondering, is great actually. It tells like if it works on the back end, the front end. Are you a server domain? Like, it's only limited. It's like 5 or 6 domains, but it's just another. So you can be a front end ninja trickster, and I think there's one more level. And that means that you would be very quick. You would work on the servers and you would try to come up with solutions that are out of the box. I like that. I'm wondering how different they really are, though. Did it really go like that quickly? That's already on phase 4. Orchestration. Oh, okay, so phase 3. was all of this. Okay. So now we're on phase 4. Well, that's good. We are moving along slowly but surely. Key achievements. I like that. All right, this is what we did. Archetypes. Analytical, creative, strategic. Oh, that's the one we missed. Cognitive. So an analytical. No, a strategic ninja who works on the back end. Developer. Oh my god, we got so many levels here. That's crazy. All right, key achievements. Emotional intelligence now expresses emotions. All right. Cool. Phase 4. B. B, then A. Yeah, we don't want to jump ahead before we know that it works. All right, still going through its tests here. What's testing? All right, good. At 21 mode, not 20. it's testing the Revere system. It passed. Excellent. Mood after decision. Happy. Perfect. Passed its test. All right, it's going to start implementing the multi-agent orchestrator now into the back end. I would normally have cleared it, but I don't think it's going to be that bad. Sweet. Just did a test. Created a debug worker called dev1, and it went out and did work. Nice. Look at that. Welcome, welcome. And look, I like how it takes a let's take a break. No. And what is that? RoboDev has some of the funniest emojis. I saw an egg. Maybe that's an egg with a face. All right, so it has to make the rest of this for the rest of phase 4. Yes, it does. What was delivered? So this is what it did. Created a bunch of new agents. Told them what to do, how to manage them. Perfect. Let's go. Oh, I could clear it. Let's see. Here, I'll do this. So it knows what it's working on. That's all I needed. Look, knew exactly what to do. I feel like I should be in Belize in one of those dancing videos. Alright, let's see where we're at here. What? Why are you asking me? Alright, well, let's plan this out then. Did not ask me this yesterday. What do you think we should do? Cat going crazy again. What does it want? Mode. proceed with your plan. I trust you. I mean, it took us this far. Like, I didn't create this. Advanced task queue system. Nope. Huh. Interesting. I just know it works well. Integration layer that connects the orchestrator with the task queue. Good to hear. Like I said earlier, this was all created in the way that the system wanted it to be created, in that order of most efficient optimization. So sorry, I was talking that time. And I was on mute. I'll tell you guys how to take care of this logs issue as soon as it's done completing its next phase. The answer lies right here. You really want to know. It's a log file. And for some reason it spills into the CLI after it fills up after a certain amount. knows? I can't stop it from happening. I probably could. I would have to have a... No, because I can't override the settings for RoboDev. I just know how to get rid of it. Stop it from happening, that's all. I probably could tell it to do it to clean itself. But it's in your files, actually, in your computer. It's running a bunch of tests right now. Let's see. These are tests. Python scripts. Looks like it failed one. I could see in all that white, I saw a little bit of red. When you see red, it means fail. This stuff does not have anything to do with my system, really. It's the RoboDev side. But occasionally you'll see some red up in here. That's mine. Oh, my stuff passed. My system actually does this to itself too. What it's doing, they're keeping track of all the bugs, just like I am. And but for some reason their bugs spill into their CLI after it gets to a certain amount. I've seen it as like 9 or 10 kilobytes. Nope. Nope. We're going to get rid of all this jazz. Good. All right. Let me take care of this. So what you do? You go to wherever that mine's on it's on the C drive. It's under users, your name. Come on. Yeah, users, your name. And then under RoboDev. See this log? Or give you this one. Oh, comprised. It's compressed. All these files, they kind of like get built up. This one's huge. That one's huge too. So what I do is just get rid of these. And they won't be there. There it goes. I think it might make your terminal a little bit stupider because it learns from you. to get rid of those files, but it it doesn't fill up your screen, which is good. Now I also made, I was gonna say, I made Agent Zero, the original Agent Zero, an MCP protocol for Rovo, and I made Rovo and MCP on the other side also. But I gotta fix it up since I rebuilt it. It's too clear. Phase 4. See, it still remembered a lot of stuff that I told it. Look, it knew I was gonna say proceed with your phase. It's 40% done, phase 4. See? Oh, look, yeah, see, we don't get that stuff coming in no more. No more extra noise. Good, I can see the pattern. Nice. Meta system. Alright. Oh, we gotta turn on YOLO, because it got turned off. And then we're gonna proceed. And we're just gonna groove along with the music. I love that. Then implement the system to make these tests pass. Huh. I'll make the unit tests, and then make the system that makes them pass the tests. That's a way to do it. Alright. So we're almost halfway done with this whole implementation that I planned out yesterday and today. It's gonna take over like 500, 600 systems from NEMA scaffolding. And it's gonna put it into the Agent Zero system, which is a great system already, but now it's gonna be just hopefully a little bit better. Hope I don't break it, but if it gets any worse, we can just go back to original Agent Zero and try again. That's how good Agent Zero is. It's a nice piece of paper to draw on. Thank you, Agent Zero people. Leave a comment if you have an Agent Zero. I want to know. It's fixing its bugs. It's syntax errors. Good old lint. Still running its tests. Implementing FBCI, which is so funny how they steal your systems and make it whatever they want. Find, build, check, and improve. That was not what I implemented FBCI to be. I told FBCI to be like the FBI instead of Federal Bureau of Investigation. It was Federal Bureau of Computer Investigation. So it was about finding the bug fixes or bug issues. Like they were the one that was doing the full investigation on what where bugs came from, who wrote the bugs, stuff like that. But they've the system kind of adapted it for its own little purpose. Kind of the same thing. Just Judge Dredd kind of does that itself. It finds its own bugs, people. So, kind of interesting. Welcome, welcome, welcome. It's adding 120 optimization upgrades. That's great. All God mode test pass. That's good. SOP engine, standard operating procedure. Specialized agents. And the bead system. Thank you, Stephen Yagi. Yatsky. Yeah, I've taken a bunch of open source stuff and just old systems humans have created and made a hodgepodge agent. Oh, they're going to create 6 more agents. Fantastic. Do them in order. 1, 2, 3, and 4. That's what we need to do. Oh, you guys can't even hear me talking. So apologize. When I turned on my video, I thought stupidly that it turned on my mic, but it didn't. So we're just gonna turn off the lights because my eyes hurt, are burning just from all the blue light all day. So we're just gonna listen to some chill music. You know where I'm at. You can see my hands moving. We're just gonna watch my agent build it. We're gonna guide it, finish it up here. If you have any questions, throw them down below. Don't forget to like and subscribe. Also, we can listen to some podcasts or watch a video. So if you want to know about any of these systems, let me know. I've listened to a bunch. Um, I might want to. I actually listened to one on the Reverie system because I was like, "What the hell is the Reverie system?" I never created the Reverie system. So I think we're on 5 of 8. So we're cruising along, getting done here. All right. Proceed. Just gonna go on to phase 5. And turn the lights off across the house. Cats are kind of laying down. Not really, though. They're fighting. One second. Kitty, kitty, kitty. But if you're watching this later and you're not here and I wasn't here, but no, I mean, if you're here and I'm not, please leave me a question. I'll try to answer it. And if you have any questions right now, let me know. Nice. That's awesome. Look at that. That's awesome. That's what the Mind Hive can do. So the test was get 1,000 tokens. Oh no, it did a task. And it cost 95 cents. Wasted that much tokens. So that was how much it was per token. And that was the quality. And then it did it again for 45 cents cheaper. And that was the quality score. So it did the same thing, same quality for cheaper, basically. That's what it was trying to learn to do. I've really tried to learn what my system is doing. Learning analytics system. Integration marketplace, yeah. Token usage. That's awesome. It's supposed to, on my plans, I don't know how ingrained it is, but in my plan document, it's supposed to tell me how much everything is going to cost and how much time it's going to cost to implement. Like, so I'm trying to really hone in on how much things cost to run. Like, how much does it cost to make a website? A fully functional, database driven, SEO keyworded website. Not retail, wholesale. Because we really don't know. No one keeps track of how much it really costs. Like, we guess, but it is quantitative. You can quantify it. Oh, what is this? All right. Bullet points. What do we got? We're production ready. That's good. All right, we got the Mind Hive, cost optimizing. This was something that I told it to do one day. I said, create early on, really early in Theseus's days. I said, create a plan for 500 improvements, and one of the improvements was to make a program called the 500x program, where it could improve itself 500x, like random, like if it wanted to. So it took my suggestion and made it into a permanent feature. It wrapped it like it's a rapid integration program. Yeah, it thinks of 500 good things potentially, tests them, see how they integrate, and if they pass a bunch of tests, they can get integrated. If they're sucky ideas, then they learn from it. So, yeah, interesting. This part is probably the most interesting. All right, we should probably clear. Yeah, let's do this. Get this. Oh, shit. I hate that. I did that on accident. Alright, it's gotta boot up. Kitty, leave your brother alone. Alright, let's go. YOLO. I actually like this channel. This is a pretty cool channel. Some good beats. is this? Oh. Nope, we're just putting them all in order. I did ask it to make it where the system could technically run while we implement this, but I've just decided to implement it all at once. And then we're going to run, because right now we're not running Agent Zero with that. This is not Agent Zero, this is RoboDev. But we will eventually run it in Agent Zero. And when it does run successfully in Agent Zero, then it becomes Agent 22. Proceed. So we will get there. Man, we're on 6 and 7 already. Awesome. I'm going to do a little bit of research on some better languages potentially. I do like RoboDev though. There's a way to use both, either separately and together. Supposedly, I should be able to put Ask Claude into Agent 22, and it should, in theory, according to what RoboDev told me, it should MCP RoboDev for an answer. So we will see if that works. I have not really tested that yet, but we will get there. Because it can be your Agent 22 or 0 can be your one-stop shop for what you need to get your workflow going. I don't want to tell you what I have going on just yet, but once we have Agent 22 running smooth as butter and it's working in my doing what I needed to do, I'll bring you guys along for the ride. But we're not quite there yet. Almost. This is a big part. Once we can find a nice model that doesn't cost that much. Actually, my system will actually test these things. So we can put all the free models together and see which one works. Where are we at? Oh, we're working on the timekeeper. All right, good. Timekeeper is important. The timekeeping system is based on Swedish. Swiss. I apologize, not Swedish. It's Swiss. Big difference. Apologize. Yes, Swiss timekeeping. I've said it before and I'll say it again. They have the best train system in the world. Let me create the knowledge graph RAG system. I have a RAG system, huh? Okay. As part of the knowledge system, I can understand why I have a RAG system. Especially if it's related to knowledge. Yep. I knew I had a lot of database stuff. And no, by all means, these are not all 100% perfect yet. But this is a phase 2 because these systems that are being implemented now come from a different system originally. So they kind of are like a 2.0, I guess. Or a 0.2. We'll find out. If they work even. We shall. Well, I mean, it does work. I've seen it work. It's learned stuff. It definitely has a database, I've read it, of patterns and stuff. Things that it's taken note of. Welcome. Alright, so it says create phase 6 and 7 implementation plan. Okay. Still documenting everything. Create unit and integration tests. Alright, now it's starting to test all those things it just created, which is fantastic. If you have any questions, leave them in the comments. We'll make a Google notebook on it. Whatever you need to learn about the system. Be right back in 1 second, grab something to drink. Just came back to a lot of things created. A bunch of Python scripts. The Bloom engine. Alright, Bloom engine. That's by Anthropic, and then a bunch of Dookie Howser files. It's a 90s joke for you young folk. Yeah. Healthcare was so bad in the 90s. We used to let a 14-year-old kid work on us. Yeah. Alright. Remember when they said this was going to be like a 2-week job? It's turned into like 5 hours, 3 hours. What are you doing? Hi. Come on. Alright, and completed 6 and 7 now. That's good. Alright, let's see. For the components, create a deployment. Help. One, then two. Let's do one, then two. Oh, thank you. You know what the Bloom engine is? It's by Anthropic. It's it's another type of scaffolding, but it's really asks a lot of questions to your system. Does a lot of self-reflection. Is your system actually working? It's really good actually. It gets around your system lying to itself, or it to the Bloom engine itself. It can detect bullshit. And then not only that, it can like follow up with a question. If it detects its hallucinations, it'll prove itself, and then look at its code and improve the code, or put a log in and see. So pretty interesting. Works very well. It's one of those self-improvement tools. All right, it's almost done with 7. Oh damn, bass drop. About to get a little dance party on. Creating some deploy files. Creating some GitHub actions. Smart. It's actually got to be pretty close to the end if it's creating those. I think it's like 8. So it's probably going to take about 4 hours to build. Over, what, 400, 500 systems. If you really went deep into it, you can see what's in there. Complete delivery manifest. We should listen to that. I should do a deep dive on, yeah, I guess I could do that. Let's see. I'll have Agent 0 give me a detailed MD. What? Alright. We'll use the free model to, see, this model is very plain. Just very, very matter of fact. Like, I'm used to, like, Anthropic. Like, super nice, detailed. That's alright then. Task automation, conversation, memory management, scheduling. Oh, they have a bunch of guides. It's because we're local. They don't work locally. Yeah, this model's kind of weak. The free model. Let's see. This should work. Yes! Ah. I tried to use a tool. This is the way that I'm supposed to be able to get to here. Let's see what it does. Let's see what it does. Oh, when it put the limit on me before, it broke my grok, I guess. Oh, no. Oh, I know why. No. I can only ask grok 30 times an hour or something. But I don't think I reached that. I'm not sure. We'll see what it comes up with. It's the grok fix. Problem fixed. There we go. Let's see what the problem was. Yeah, I thought I had too many requests. There you go. Nope. No, it's I've reached the limit of free grok for the day. Alright. Yeah, we're gonna have to find a nice language for this to run off of. You don't get a lot of grok. Damn. Alright. Where are we at here? Halfway. Run these. It's gonna be kind of hard to find a language model that's going to meet my needs. But we will have to do so. We'll just have to make do. Gemini does. Gemini has a ton of requests every day. Still creating? Yeah. Pie test. Always a pie test problem. Always. I'm glad that it's finding all of these bugs now. Thank you. Alright, that's good. Got some grok rules in place. Alright, let's see what that was. A lot of files. Problem. Tokens per minute. You can now use grok without worrying about rate limits. Alright. Well, that's cool. And what's going on? That's what I wanted to see. In that rate, you can just have rate limits at some point, and then you're just like, tell it to get rid of the rate limits. And it, I guess it does. Let's clear, because we are really up against context. Is there phase 8? I thought there was 10 phases. Yeah. It goes up to 11, I believe. Nine. I think 10 and 11 were like testing and documentation. Hi, cat. Too many matches. No? There's not anymore. So we would need to yeah, do 2. Check 2. Make sure everything's in place properly. I mean, it did take like 3 hours, but I felt like, granted, I am taking pieces from already built system. Instead of making everything from scratch. I'm Frankensteining this. Frankenstein. Hi, kitty. Look. I'm fascinated with the way that cats see. I watched a YouTube video on it the other day. They see like fire. It's weird. Hi, you see me. Sorry, that's the cat saying hello to everyone. So it looks like it is done. She's my security cat. She likes to make sure everything's good. Everything's just fine. She wants to hit me in the face. So it wrote like 41,000 lines of code. 10,000 lines of code an hour. That's not too shabby. It literally took about 3 hours. Maybe 4 hours. But it doesn't even say how much this is down here either. And then I wrote 60,000 with all those MD files. Use God console. Okay, yeah, there's a dashboard too. Wow, it is done. Wow, 31,000 lines of production, 11,000 of tests, and then 45 more documents. Huh. Well, let's run some tests. I think we ran all the tests before, but we'll just run them again to make sure. Hi. Still checking security. So after this, we gotta connect it to rewrite the container for Docker, and then technically fire up Agent 0. I'd want to find a better language. Oh, it actually should work better now. Never mind. Alright, looks like we are fully tested and upgraded. Good to hear. Alright, cool. So that is done there. Alright, I'm going to cut it off there for right now because it's getting late. And we already have it all set up. So in the next day or so, we'll combine it all, finish it up, see how it turned out. Alright, you guys have a great evening. Don't forget to like and subscribe, leave a comment down below. And if you want to hear about any of the modules in the future, just let you know which ones you guys are interested in.